We're now going to have a look at objects that are discrete and the errors that come across with that. So what I mean by an object that is discrete is something that can only be counted in ones. So people, they are discrete objects. You have one person, two people, three people, that sort of thing. You don't have 2.5 people. Now, obviously, if we work out the mean of something, we may end up with 2.5, and that's absolutely fine. But in terms of counting them discretely, you go up in ones. Okay? So a fact that we just have to know is that discrete objects are always going to have an absolute error of 0.5. So think about that in terms of when we're rounding to the nearest whole number. So say I've got 3 metres and I've rounded that to the nearest metre. The smallest it could have been to allow that to happen is 2.5 metres, and the biggest it could have been to allow that to happen is 3.49 metres. The absolute error here is 0.5. The absolute error here is 0.49, and we choose the larger of the two. So 3 metres plus or minus 0.5. So we've done that a few times already. This is the same idea. So that's where the absolute error of 0.5 comes in. Okay, so we've got a wee example here that involves that. So we've got a biologist is sampling a woodland that is 3.2 kilometres by 2.1 kilometres. And they have a precision of 0.1 kilometres. The biologist then samples 1 square kilometre and finds 34 toads. So we want to estimate the number of toads in the entire woodland, and then we want to get the relative error of that calculation. So the calculation that I've already done sitting here is what we've done many, many times before. So this is our area error calculation. So we've got the measured area, which is 3.2 times 2.1. The smallest that can be, so I've subtracted 0.1 from both measurements and then worked out the area there, and then I've added 0.1 to both measurements and worked out the area there. So we can get our absolute error here. So the absolute error between 6.72 and 6.2 is 0.52, and then my absolute error here is 0.54 kilometres squared. So we choose the larger of the two, so this is my absolute error of the area. Okay. If I then want to turn that into a percentage error, I'm going to take 0.54, divide it by our measured area, so 6.72, and then multiply that by 100 to turn it into a percentage. So 8%. Okay, so that is our area relative error. So it's asking me to estimate the number of toads in the woodland. So now that I've got the measured area of 6.72, if I take 6.72 and multiply that by 34, because there are 34 toads in a 1 kilometre squared, that's given me 228.48 toads in the woodland. However, there is an error for that. So we know that there's an 8% error in the size of the woodland, but there's got to be an error for the number of toads that have been counted as well, because, well, toads might jump around a little bit. Okay, so if we think about the toad relative error, because they are discrete objects, the absolute error for the toads is 0.5. So I'm going to take 0.5, divide that by the number of toads per kilometre squared, so 34, and then multiply that by 100. So that's an error of 1.5%. So the total error for the whole thing are my errors combined. So my area error plus my toad counting error, so 9.5%.